In this example, we'll find the general solution to the differential equation y double prime plus 4y prime plus 4y equals e to the power negative 2t times ln of t. So we're going to follow our steps for the method of variation of parameters. And the first step here is that we have to find y1 and y2. So to do that, we look at the auxiliary equation. And the auxiliary equation is r squared plus 4r plus 4 equals 0. Now, we can use the quadratic formula, but we could also see that this factors as r plus 2 squared. And when we set that equal to 0, we then see that r plus 2 has to equal 0. And so r equals negative 2 with multiplicity a multiplicity of 2. And our two solutions, y1 and y2, y1 of t is e to the power negative 2t, and y2 of t is equal to e to the power negative 2t. Because of the multiplicity, we get an extra factor of t here. Second step, we want to find the Wronskian. The Wronskian is given by y1 times y2 prime minus y1 prime times y2. And so y1 is equal to e to the power negative 2t. And now we need the derivative, so let's do this. Maybe over here, we see that y1 prime is equal to negative 2 e to the power negative 2t, and y2 prime, we have to use a product rule, and so that's 1 times e to the power negative 2t, and then minus 2t e to the power negative 2t. So y2 prime, we have to multiply this by e to the power negative 2t minus 2t e to the power negative 2t. And then minus y1 prime is negative 2 e to the power negative 2t times y2, which is t e to the power negative 2t. Okay. Let's distribute this. We have e to the power negative 4t. You add the exponents, and minus 2t e to the power negative 4t. And then this becomes a plus. So we get plus, and then 2t e to the power negative 4t. And we see that these two terms cancel, and we're left with e to the power negative 4t. So the conclusion is the Wronskian of y1 and y2 is e to the power negative 4t. The third step is we want to find f1 or v1 and v2. So we recall the formula from the second video. V1 is equal to the antiderivative of negative f times y2 over a times the Wronskian of y1 and y2 and that is equal to negative f. That's the negative of this function, so that's negative e to the power negative 2t ln of t times y2. We found y2 here, so that's times t e to the power negative 2t. And then we divide that by a, and we see that this is our a equals 1, the leading coefficient. And so that's 1 times e to the power negative 4t. Now, we can simplify this by noticing that e to the power negative 2t times e to the power negative 2t gives us e to the power negative 4t, which cancels out with the e to the power negative 4t here. So this together with this cancels out this. And so what we're left with is the following. This is equal to negative the integral of t ln t. Now, in order to find that antiderivative, we're going to use integration by parts. So let me remind you of that. Integration by parts. Integration by parts says that the integral of u dv is equal to u times v minus the integral of v du. Now, the way it works in this equation right here, we can let u equal ln of t, and then dv dt is actually the t. So we're going to let this be v prime and this be u. And so what we find is that du dt is 1 over t, and in order to find v, we have to take the antiderivative of this, and so we find that v equals 1/2 t squared. And in order to rewrite this here to find what is du, we just multiply both sides times dt, and we get du equals 1 over t dt. So we have all our ingredients, right? We have u equals ln of t. We have v is 1/2 t squared, so that gives us the u times v. And then v du, we also have du right here. So now, if we use all of that together, we get the following. So this is our integration by parts on the side. And we're going to use that for this differential equation. We get a minus in front of all of this. That's the minus that carries over from here. And then we have u times v. So that gives us u equals ln of t times v, which is 1/2 t squared, and then minus the integral of v, which is 1/2 t squared, and then times du. So this is v, and then du, that equals 1/t dt. Right, and just as a clarification, this is u times v, and then this is the integral of v du. Okay, now let's simplify this. So the first term becomes negative 1/2 t squared ln of t, and then distribute that minus. We then have plus the integral of 1t cancels here, so that's 1/2 t dt. And this integral, we can use a power rule for that. And so that becomes plus 1/4 t squared plus c. And so as a conclusion, we find that v1 of t is negative 1/2 t squared ln of t, and then plus 1/4 t squared, because we're going to pick that constant of integration. We're going to pick that to be 0. Okay, now it's time to take a look at v2. v2 equals f times y1 over a times the Wronskian of y1 and y2. And so that is equal to negative e to the power negative e to, or sorry, not a negative. We don't have a negative. So it's equal to negative e to the power, or it's equal to e to the power negative 2t ln of t times y1, and let's go up here. y1 is e to the power negative t, so it's e to the power negative t, 2t, and all of this over 1 times e to the power negative 4t dt. And just as before, the powers of e cancel out, and then we're left with just the antiderivative of ln of t. Now, we can find this again by using integration by parts, which I won't do here, but I'll just give you the solution to this. This is t times ln of t minus t plus a constant of integration. So I would verify that you can find this. So integration by parts, and what you can use here is that u is ln of t, just as before, and then dv dt is equal to 1 instead of t, and then see if you can do it the same way as before. Okay, so the conclusion for V2 is that V2 of t is t times ln of t minus t. Again, we pick c equals 0. Okay, and for the fourth step, we find yp, which is v1 y1 plus v2 y2. And so what we find is that yp of t is v1 negative 1/2 t squared ln of t plus 1/4 t squared times y1, which is e to the power negative 2t, and then plus v2, which is this one right here, t ln t minus t times t e to the power negative 2t. Now, it turns out that you can simplify this quite a bit, because we have a t squared ln t here, and if you distribute this t, you get a t squared as well. And so yp of t, if you simplify it all the way, we actually get 1/2 t squared ln of t minus 3/4 t squared, all times e to the power negative 2t. So again, verify that for yourself, that when you distribute this and then collect like terms, that you get this answer here. And then finally, our general solution, y of t equals the solution to the homogeneous equation plus yp of t, the particular solution. And the homogeneous equation, the solution is c1 times y1, and y1 is this one right here, so that's e to the power negative 2t plus c2 times y2, which is this one here, so that's c2 times t to the power, or t times e to the power negative 2t, and then plus the particular solution, which is given by this, and so that's 1/2 t squared ln of t minus 3/4 t squared times e to the power negative 2t. that's our final solution to this problem.